In Chapter 6, we're going to talk a lot about factoring polynomials. Factoring you can think of as the reverse of multiplication. So the work we did in previous units multiplying polynomials, this is going to be the reverse of that. Let's think of an example using just a number. Suppose you had a number like 21. To factor 21, you could do 1 times 21 or 3 times 7. That's what it means. Factoring something, you break it up into pieces that you could multiply together to get what you start with. And the first thing we're going to look for is what's called factoring out the greatest common factor. Let's begin with 3x minus 15. Here we have two terms, 3x and minus 15. What we want to do is to try to find something that both of those terms are divisible by. And if you look at 3 and 15, they're both divisible by 3. So we're going to put that thing they're both divisible by out front. 3 is what we call here the greatest common factor. And what we want to do, to see what's left, we're going to divide each of our original terms by 3. 3x divided by 3, the 3's would cancel out and you would just have x left over. Minus 15 divided by 3, you would have a minus 5. And notice if you did take the time to distribute the 3, you would end up with 3x minus 15. So here we've done what's called factoring out the greatest common factor. Find something that both terms are divisible by and pull it out to the front. Let's take a look at another example. Here we have 3x to the fifth plus 12x squared. So we're looking at the 3x to the fifth term and the 12x squared term. So thinking of the numbers 3 and 12, those are both divisible by 3, so we're going to factor out a 3 again. The thing that makes this one different than the previous problem is the variables, x to the fifth and x squared. When you have a variable that is in both terms, you can factor out the smallest of the powers of the variable that are there. So looking at x to the fifth and x squared, our smaller power is the x squared. So to figure out what's left to go in the parentheses, we're going to divide each term by 3x squared. 3x to the fifth divided by 3x squared, the 3's would cancel out. X to the fifth divided by x squared, you might remember from a previous chapter, when you're dividing, you subtract the exponents. 5 minus 2 is 3, so we would have x to the third left over. In the next term, the x squared and x squared cancel each other out completely, and 12 divided by 3 is positive 4. So this would be our answer, 3x squared times x cubed plus 4. Let's try a few more. Our next one, we have 5x cubed minus 15x squared. So first, I look for a number and see if there's a number that I can factor out of both parts. For 5 and 15, those are both divisible by 5. Next, I look for a variable. We have x cubed and x squared. So there is an x in both terms, and I factor out the smallest power of the variable that's in both terms. In this case, it's going to be x squared. So to see what's left that's going to be in the parentheses, I take each of those terms I'm starting with and I divide by whatever I'm factoring out. 5x to the third divided by 5x squared. The 5's cancel out completely, and x to the third divided by x squared is x. Then we have a minus. 15 divided by 5 is 3. X squared and x squared cancel each other out completely. So our answer would be 5x squared times x minus 3. Let's look at the next one. Here we've got more variables, but the process is going to be the same. So here we've got our three terms, 8a cubed b squared, 16a squared b cubed, 20a cubed b cubed. So first let's look at the numbers, the 8, the 16, and the 20. We want to find something that all of those are divisible by. Sometimes students look at the first two terms and say, oh, 8's divisible by 8, 16's divisible by 8, I'm going to factor out an 8. The problem is that the 20 is not divisible by 8. We want to find something that all of the terms are divisible by. Now, another student might look at this and say, oh, well, they're even. They're all divisible by 2. And that's true. They are all divisible by 2. But you want to think of the largest thing that they're all divisible by. And in this case, the largest thing that they're all divisible by is 4.